Welcome back. It's 10 a.m. and we continue to have very interesting snow developing throughout the region. Snow has now broken out throughout all of northern New Jersey, Long Island, and Newark. Finally, we're getting light snow, around 2 miles visibility. But the real interesting evolution here is what's going on around Trenton, where we're getting light to moderate snow, visibility of 1.25 miles. Around Belmar, snow is continuing, temperature around 29. Around Wildwood, we have snow and a little bit of sleet, a little bit of mixed precipitation around 32 degrees. Atlantic City, light snow, about 1.5 miles in visibility. And then off towards the west around Philadelphia, we're seeing snow again, steady snow occurring at about 28 degrees. So we have snow throughout the region and some moderate snow showing up. When we take a look at the radar, a lot of interesting keys here, a lot of interesting observations showing up here with the radar, showing moderate band now to the north of Trenton. That wasn't really expected. This band was expected to be more down here. If you were following all of the mesoscale models, the HRR and the NAM model guidance, that was all suggesting that you'd get these bands taking shape down here rather than up here. So very interesting observation showing up here. We'll see how long this continues as this continues to evolve throughout the morning with that moderate band. Let's break down the levels here. Now, when I look at the radar, I'm using WeatherTap, and I have all these different levels I could look at. Some of these levels I use to study during severe season, high res vertical integrated liquid. How strong is the process from the ground to the mid levels of moisture transport. Echo tops, obviously the top of thunderstorms, VAD wind profile, and enhanced echo tops you can use for severe thunderstorms. Coefficient, this is how you find your rain snow line. And then you have these different levels in terms of radar, from composite, where all the levels together, and then various levels of the atmosphere, kind of segments in tilt 1, 2, 3, and 4. So that's what we're looking at right here. We'll add on tilt number 2 here. And we'll start here with the overall composite, and you can see that moderate band taking shape around Ewing to the north of Trenton, moderate snowfall in northern Monmouth County. Now, when you have a band here, you get subsidence here and here around eastern Monmouth County. That's why you're getting lighter snow on the coast here, maybe a little bit of mixing. Another band is taking shape right around Philadelphia from Camden down through Wilmington, and that is producing some moderate snowfall. And then when you break it down to the lowest level, level 1, you can see where these bands are really taking shape here and starting to really organize as we go on through the morning hours. And when we move that, you can see that they're just growing in size. So why are we growing in size? What is evolving here in the weather pattern? Well, our low pressure system has now formed off the coast, and it is intensifying steadily. It's moving off to the east as expected. We're getting this stretching back because of this short wave trying to catch it. So it's kind of throwing a hook on it and trying to pull it back to the west. Not going to succeed, but it's going to cause stretching in the atmosphere. That leads to that inverted trough development. And you can see that also on the water vapor satellite picture. Pretty nice lifting here with our shortwave into subtropical jet stream. Here's our polar shortwave coming in, trying to catch it. And you get that pull taking shape right here. So at the surface, what you end up with is this trough that's starting to take shape here, cutting up towards the Delmarva, back through southern Virginia, and off towards North Carolina. So when we look at the different levels of the atmosphere with that surface development taking shape, you can see at 300 millibars, this is our upper level wind. Here's our jet stream continues to intensify. Here's all the lifting, all the jet dynamics taking shape over New Jersey, back down through the southern mid-Atlantic. Then the frontogenesis, interesting enough, not a lot of frontogenesis over the mid-Atlantic at 700 millibars. But when we go lower down the atmosphere at 850 millibars, this is where we're starting to see the frontogenesis, that lifting that I was talking about, taking shape around central New Jersey, actually to the north of what I thought it would actually set up around portions of New York City back through Trenton into southeastern Pennsylvania. And so that's why we're getting that band just to the north of Trenton. We'll see how long that continues or if it starts to shift south as our storm continues to evolve. At 925 millibars, this is showing up pretty nicely over New Jersey back through the southern mid-Atlantic. So it's pretty much taking shape. We got a nice 925 millibar low starting to take shape here. Here's the other one with our core, our primary storm, and that stretching back influence. And you could see in terms of our shortwave coming in, here it comes, getting ready to try to capture our storm. It's not going to do it in time, but it's going to be enough to cause that inverted trough, that stretching in the atmosphere, and that evolution. So when we take a look at the latest HRR guidance, and what I'm doing is I'm just looking at the initialization. I'm not so much worried about what the model is doing right now because I got the storm right in front of my face. I don't need the guidance. So I can see what's evolving here. And you can see over central New Jersey, right around where that band's taking place, you can see that conditional instability showing up here. You throw in some lifting here and you get your band, and that is essentially what you're seeing here. You're seeing instability, then a stable pattern with no, just neutral, and then another instability layer, and then neutral again, and then a little bit warmer here at 600 millibars. So you're seeing that instability showing up very nicely here, and that is why we're seeing what we're seeing here. So we'll continue to keep an eye on this evolution of the storm as the dynamics continue to change. And we'll see exactly how long that band stays to the north of Trenton or whether it drops south. Interesting times ahead over the next couple of hours. And of course, I'll be right here doing the update. So I'll see you next hour. And as always, stay safe out there.